Hi, it's Bruce, and welcome once again to my Colorado Rocky Mountain lab. Today we're taking a look at a Keithley 177 Microvolt DMM. It's called a Microvolt DMM because its lowest range of voltage is 20 millivolts maximum, and with 5.5 digits, that would put us a good 3 to 4 digits into the millivolts, so we're talking microvolts. The unit is in extremely nice looking shape. Case has got extremely light scratching, if anything, on it. It's almost in like new condition. Beautiful. Very, very bright LEDs, very large, easy to read. You could read these across the room without a problem. There's our specifications on the bottom. All the ranges. It has a nice stand, very good shape. Very hard to fault this unit. It's in beautiful condition. We're going to be taking it through its performance just to see how we do, and if you'll bear with me, we'll get started here in a couple of minutes. One of the really nice things about these series of Keithleys, 177, 78, 79, they've all got a shielded calibration plate in here. It gives you shielding. It's shielded. The bottom side of the chassis is shielded, and this provides shielding for the top. But along with that, they've silk screened a set of directions for calibrating this unit, starting with step 1, which is right here, apply your short. Step 2, open the input and adjust for 0, and so on. And you go through and step by step adjusting the dials that are in the holes that are next to the calibration date or information. You will step through all of the calibration, and when you get done, it works beautifully. What's required is a nice stable set of voltages and a good reference meter just to kind of double check things. In my case, I'm using the 343A calibrator for the DC, and I've got a Fluke 5200A for the AC, and I have this Hewlett-Packard 34401 or this Keithley 2015 that I use as a reference. But keeping these meters up into a calibrated shape is very easy. Just thought I'd show you. Okay, we got the 177 connected up in DC volts. We're running the voltage from our 343A, and we're simultaneously measuring the voltage on this Hewlett-Packard 34401A. Right at the moment we are on the 20 millivolt scale, and we are feeding in 10 millivolts essentially. We're getting a reading of 9.996 to 7, we'll say 6. And on the Hewlett-Packard, we're getting a 67, 9.996 to 7. So within roughly a half a microvolt of each other. It's pretty fabulous at this range. And we're going to go ahead and go to the 200 microvolt range. We see our 10, and we're going to up ourselves now to 100 microvolts. We're settling in between all 9s and 100. And we have 99.9875, so 99.99 would be the rounded. 99.99 to 100, so we're right there within a digit. Going to the 2 volt scale, There's our 0.1 volt. And here is 1 volt on the 2 volt scale. We're reading 0.999998. So you round up one digit and you're there. We're flashing between all 9s and 1. Going to the 20 volt scale. There's our 1 volt. This should be 10 volts. Going between all 9s and 10. Looks like we're settling in there. And here we are at 9.99998 again. We are different by 20 microvolts at 10 volts, maybe. And if you do a round on that, then you're right there at 10 to within 3 places. So that's fabulous. Let's move on to the 200 volt range. There's our 10 volts. Alright, we want to go to 100 volts. 99.99 to 100. 99.9986. 999. Again, you know, within the last, what is that, 500 microvolts? Within 500 microvolts of being totally the same at 100 volts. Alright, going to the 1000 volt scale. There's our 100 volts. There's 200, 300, 400, 5, 6, 7, 8, 9. 999.994 and 1000.0. So within 5 millivolts of being perfectly the same at 1000 volts. Extremely small error. So DC wise, we're doing extremely well. Guess we should move on to AC. Okay, we've connected the 177 up to the AC output of the Fluke 5200A. We're feeding in a 1 volt signal. Okay, we've got 1 volt at 1 kilohertz coming into the Keithley. We see that we get 1 and 4 zeros. We just flashed all 9s, but that's... And the Hewlett-Packard is telling us that it's 1 to within 5 significant places, and then we bobble a little bit in the microvolt range. So we're looking really good there. That's on the 2 volt range. Okay. So our AC ranges do not include the 20 millivolt range. AC begins at the 200 millivolt range. We're right now reading 9.99 millivolts. And we see that our Hewlett-Packard is running from all 9s to 10. So I just saw it flash 10 over here on the 177. So we're real close at the 10 millivolt range, but let's go up to 100. Okay, we're on the 200 millivolt range. We've got 100 millivolts showing on the 177. And we see ourselves on the Hewlett-Packard at 99.99. So we are about 10 microvolts higher than the Hewlett-Packard. Yeah. So essentially right on top of it. Let's go to the 2 volt range. Alright, so we are on the 2 volt range on the 177. We're feeding in a 1 volt, 1 kilohertz signal, we're reading 1 volt, and the Hewlett-Packard is reading 1 volt, better than 5 places, almost 6. So we're reading that very, very nicely. Let's go to the 20 volt range. We are now reading 0.998. Let's go to 10 volts. We are reading 10 volts. We got 10.007. And we have 10.0000. So we are about 7 millivolts high at 20 volts. Alright, we're on the 1000 volt scale, and the highest voltage I can provide AC wise is 110 volts. Right now we're flashing between 109.9 and 110. And our HP is saying that we are 110.015, so 110.02. So there's, I don't know, about 20 millivolts difference out of 110 volts AC between the two units at 110. I wish I could go higher, but I have nothing that produces anywhere near 1000 volts AC. DC I've got. Okay, we've got the Keithley 177 connected up, reading amperage in the 20 microamp range. We're pulling 19 microamps from this Keithley 225 current source. And we are reading between 1899 and 19.06 on the Hewlett-Packard. We've got a whole nother decade of resolution on this Keithley 177. So, and we notice that the second digit isn't fluctuating at all. We're getting a little noise on the Hewlett-Packard as well, picking up a little bit. But we got 19.000 microamps, 19.001 right now microamps versus about 19 microamps on the Hewlett-Packard. So we seem to be in agreement. It's very close. The Keithley wins out on this round. Hewlett-Packard fails as a standard in this case. Let's go to the 200 microamp range. Kick ourselves up to 190. Okay, we got 190 microamps on the Keithley. We got 189.9 on the Hewlett-Packard, which would put us 100 microamps different between the two. 100 microamps. That would be 0.1 milliamp difference. But it's looking good. Let's go to the 2 milliamp scale. Go to 1.9 milliamps. Looks like that's about 1.9000 there. We got 1.89887. So rounding to the same number of decimals, we need 4 decimals, so that would be 1.8988 versus 1.9000. So we're talking 100 microamps. About 100 microamps difference. Very small difference. We're getting still fantastic resolution out of this thing. Let's go to the 20 milliamp scale. And we want 19 milliamps. 19,000, 18.994. 18.999 to 19,000, 994 still. So it looks like we're about 6 microamps off between the two. 6 millionths of an amp different. Yep. Let us go to the 200 milliamp scale. Okay. Well, at this point, we're going to switch over to another current source, one with a little greater range. Okay, well, we've connected up to this constant current power supply that I built last year as one of my projects. And we're using the constant current section of it to provide the current we need through the ammeter. And this works really well because this thing will put out up to 5 amps, and we only need 2. But it doesn't do so well in the microamp and milliamp range, whereas the 225 does that really well, but doesn't do well in the high range. So really nice that I have this thing on hand. Okay, we got 190.0. I don't know, we're bouncing around a little bit here, but looks like 3.03. We got 189.99 plus over here, so let's call it 190.0 on both. 190.0, 190.0, and there's maybe 40-50 microamps of difference between the two. Very negligible. Not even that much. Right at the moment it seems to be more like 30 microamps. Let's go to the 2000 milliamp range. And here we want to put in 1.9 amps. So okay, 1900.0 to 0.1. We're getting 1900.1. So they're in a total agreement at 1.9 amps. So the current meter is working fabulously. And look at the brightness on those LEDs. They're large, they're bright, very easy to read. Be a pleasure to have this on a bench. All right, let's move on. All right, we've connected up to measure resistance now. So we're in ohms, and we are on the 20 ohms range. So we're using this rightmost resistostat at the moment, and we have dialed in 19 ohms. We're getting 19.063. And if I check the 0, zero's good. $19.063. Okay, let's try the 200 ohm scale. And let's check 190. We got 190.04 ohms. Let's go to the 2K ohm. We've got 1900 ohms dialed in. We've got 1.9001 or 2. I'm going to say 2. 20K scale. Alright, we've got 19,000 ohms in here, and we're reading 18.999 to 19 right on the nose. Go to the 200K scale. We want 190,000. And we've got 190.01. 190.01, I'd say. Okay. At this point, we got to change to the other resistance box. All right, we've gone to the other resistance box, which has another decade of resistance on it. We are going to the 2 megohm range, and we will dial in 1.9 megohms. And we got 1.9 megohms right in the nose. All right, let's go to 10 megohms and to the 20 megohm range. Okay. We are getting 9,997 or 8. 9,998,000 ohms. So this little Keithley has proven itself in the performance verification beautifully. And it's just as beautiful physically as it is as far as its performance. So I will provide a set of leads, and I will provide a manual on CD for this unit, and package it up really well and get it out as soon as I get paid. So I thank you for listening to me, and hope you'll watch again.